adding and subtracting polynomials. Basically, it's combining like terms with a little bit more to it, but we have to make some definitions first. So we're going to talk about degrees, okay? So the degree of a monomial, and we'll use the example that they have. Example A says negative 7 x squared y z to the third, okay? To find the degree of this monomial, we simply look at the exponents on the variables, okay? So here, I have an exponent of 2, I have an exponent of 1. If there's nothing there, remember it's a 1, okay? So plus 1, plus z has an exponent of 3, so I just add these together. The value of this monomial in degrees is 6, okay? So the degree of this monomial is 6. Boom. And I will accept your answers in this form. Degree 6, okay? Let's do that again on example B. It says 8xy to the second power z. Okay, I'm adding up the exponents, so it's 1, 2, and 1, which make 4. So the degree of this monomial is 4, okay? Remember, nomial, let's define that so that we can get it in our heads now. Nomial means basically term, okay? So when you see poly in front of nomial, polynomial, then that means many, basically. Okay, so therefore mono or monomial means 1. Binomial means 2. Trinomial will mean 3. Okay, we probably won't see anything bigger than a trinomial, so we'll stop there. Okay, but you need those definitions. Nomial basically means term. So if you see polynomial, that's many terms. Monomial, 1 term. Binomial, 2 terms. Trinomial, 3 terms. Okay, and maybe we should define terms, basically. In short, I'm just going to say they're separated by pluses or minuses. By addition and subtraction. And I'll explain a little bit better what a term is here in a second when we get into different terms. Okay, so each one of these are monomials. They are just a single term. There's no addition or subtraction separating them. It's just all multiplication, so it is one term. It's a monomial. Same concept for B. So let's see if we can do C by ourselves. C gives us 12 squared. A, B to the third, C. Okay, remember what I told you on the last one. So you're only adding the exponents on the variables. So I'm going to give you a couple of seconds here. Add those up. Tell me what the degree of that one is. What do you got? 5. Degree of 5. So how did you get it? You added 1 plus 3 plus 1. So there's 1A, 3B, 1C. So that gives me 5. So to answer it, all right, degree colon 5. Cool. Is there any confusion on that before we move on? Because we're about to put a whole bunch more terms in there. No? Okay, turn your page to 336. If you would look at that chart above there. Let's see if I can show you on my end. Okay, this chart shows us a monomial, which is a 1 term, a binomial, which has, see the addition? Okay, so it is separated. There's 2 terms. Here there's 2 additions. So there's 1, 2, 3 terms. Okay, the multiplication does not count as separate terms. We're not going to count 6 and x as 1 term. Yes, subtraction. Like if there's a subtraction right there. Yeah.
Well, I mean, yeah.
We'll see some more examples of it. So the degree of a polynomial is the greatest degree of the term. Okay, so the degree of this one is just 1. The degree of this one is just 1 because the highest degree of any term is this one. This 10 has degree of 0. this 6x has a degree of 1. So here I look at each term. This x squared has a 2 degree. This 6x has a 1 degree, and this 10 has a 0 degree. So this has a degree of 2. The whole thing has a degree of 2. So we don't add up all of them. We just look at the highest term. Okay? The leading coefficient is when you put them in order. And I'll talk about decreasing order of magnitude. But when you put them in order, so I have x squared, I have x, and then no x's. That's the order that it'll go in. Decreasing order of degree there. So the leading coefficient is just the one in the front. Here the leading coefficient would be 1. Since there's nothing there, it's just the 1. There's always that invisible 1 that's out front. Okay, and then we'll talk about standard form a little bit too. Alright, so we're going to do example 2a. So example 2a gives us 2n squared plus n to the third. Okay, this is what I'll be talking about, decreasing order of magnitude. I need this to be where the n to the third is in the front. And because addition is commutative, I can just move it pretty much. So I have n to the third plus, because that's positive, 2n squared. Now that that's in decreasing order of magnitude, I can look at it and go, okay, the one up front, because that's the biggest one, is going to be my degree. So what is the degree of this? The degree is 3. Good. I take only the largest one. So the degree is 3. Is this a monomial, binomial, or trinomial? Binomial, because it has 2 terms. Okay? And I'm identifying them by underlining them. 1, 2. Okay? Alright, that was an easier one. Let's do B. This one is a little bigger. 8xy squared minus 9 plus 5x to the third, y to the third, z. So I need to write this in decreasing order of magnitude. Which term goes up front? The first, the second, or the third? The third term needs to go up front, right? So when I rewrite this, I'm going to put the 3, I'm going to write those in there. I'm going to put the third one up front. Because it's positive there, it's going to be positive up front. Okay, so I copied that down. Now, 1 or 2 is going to follow it. 1, because this one has no degree, it's 0. So since it's positive here, it's going to be positive there. 8xy squared, and then obviously 2 goes in the rear. So this one is a negative 9, so I write it down, still negative 9. Okay? Keep the signs. Keep the signs. Now that it's in decreasing order of magnitude, it's in standard form. This is standard form. Decreasing order of magnitude is standard form. I need to find out the degree of this. So I'm going to write down degree. And which term is going to have the highest degree? This one, right? So I need to add them up. 3 and 3 make, and 1, 7. So it has a degree of 7. Any questions? Okay. I'm going to give you a second to do C on your own. I'll say it out loud, so write it down. 9x squared y minus 3x squared y squared minus 5xy. Okay, do not misplace a negative. There are 3 terms here. I've already underlined them for you. Put them in the proper order. Go. Forgot to record. So we're putting the second term up front. With its negative, we're going to put the third term in the very rear, right? And the first term is going to go next. Since it's positive, I'm going to give it a positive 9x squared y. And this one remains negative, so minus 5xy. Any questions? No. So what is the degree of the entire polynomial? The degree of the entire polynomial is the degree of the highest. So which one is it? 4. It's 4, right? So it's a degree 4. Is this a monomial, binomial, or trinomial? Trinomial. A 4. It's a you know? Can't remember. If it's a magnitude of 4, it's a quintic, which which is weird. Example 3, we're going to get into some bigger things. So start copying those down. I'll say them out loud. So example 3A, open parenthesis, negative 8x to the third plus 4x squared plus x plus 1, close parenthesis, added to, open parenthesis again, 3x to the third minus 2x squared plus 7. It was nice that they put each of these terms, okay, if they're in parentheses here, okay, this is only 2 terms right now because it is only separated by this one plus sign because of the parentheses. That makes them 2 terms right now. So right now it's a binomial. As soon as I get rid of the parentheses and start combining things, we have a whole lot more terms. As of right now, while they're in parentheses, that's only 2 terms. It's binomial. But it's nice that they put them in order of magnitude already for you. So you can see easily that this negative 8x cubed is going to go with this 3x cubed, okay, when I start to drop them. Because this is a plus sign, are these sets of parentheses really necessary? Not at all, right? So I can start reordering this. Addition is commutative. So I can move stuff around, and I'm going to do it. But before I do it, I'm going to identify the things that have the same last name. So that negative 8x cubed has the same last name as this positive 3x cubed. This 4x squared, I'm going to put it in a triangle here. This 4x squared is the same as this negative 2x squared. And then I have no other x's, so I'm just going to underline my regular numbers. Okay? Combine the things that have the same shape in this case. So I have a negative and a positive. So it's a different sign difference. The difference is 5. Take the sign the one furthest from 0. So it's negative 5x to the third. Then I have a negative 2 and a positive 4. Different sign difference again. The difference is 2. I keep the sign the one furthest from 0. So it's 2x squared. We have a bad problem in this class with changing their last names. When you're adding or subtracting, you don't change their last names. You only change the leading number. Okay? Nothing happened with the x, so I'm just dragging it down. Then I can combine my 1 and my 7. They're both positive, so that makes a positive 8. And that's it. That's all you got to do. So really, in this problem, all I had to do was add negative 8 and 3, add negative 2 and 4, drag an x, and then add 7 and 1. Okay? So don't make these bigger than they really are. Most of it's just copying down. And the rest of it you can do in your calculator. So B, again, before I even write this down, do I need those parentheses? No. Why? It's a plus, not a minus. Once it's a minus, we're in a little bit more of a concern. So x plus 10 plus 2x cubed plus 3x squared minus 7x minus 2. Okay, identifying my like terms again. I'm going to square my x's. So I have a negative 7x and a positive x. I don't have anything like my x cubed, and I don't have anything like my x squared, but I do have a 10 and a negative 2. Negative 2. Don't lose that. Okay, order of magnitude says I need to put which term first. And looking at this, I have 1, 2, 3, 4, 5, 6. So which term needs to go first? 2x cubed. So 2x cubed goes up front, and that just drags down because there's nothing like it. Then what's next? Plus 3x squared, and again I just dragged that one down. Next? So it's going to be the 7x and the regular x, right? So I have a positive 1 and a negative 7, which make a negative 6x when I combine them. And then I have no more degree measures here, so I have a negative 2 and a x, which makes a positive 8. All done. Okay? How many terms are in this final answer? Say it louder. 4, right? The degree of this is what? It's 3. It's the highest order. Okay? Looking back at the one on top, it has how many? 4. What is the degree? Again, right? Alright, now the one that's actually a little more difficult is example 4. It talks about subtracting polynomials. When you're subtracting, you end up having to distribute that negative out. So example 4a is 6x squared plus 4x plus 2, and that's in parentheses. Subtract, new set of parentheses, 2x squared minus x plus 8. So here the parentheses really matter on the second piece. Not necessarily the first piece, but the second piece. So I'm just going to copy down the first piece real quick. I need to distribute this negative. I'm really distributing a negative 1, right? So this guy gets a negative, so it's minus 2x squared. This guy gets a negative, so now it's plus x. And the last guy gets a negative, so minus 8. Now I'm dealing with the same thing I was dealing with up there. Once I remember to put my negative out, I just combine like terms. So I have a positive 6x squared, a negative 2x squared. I have a regular x, another regular x, and then I have no degree measures. Okay, combine the things that I can. I get 4x squared. Combine those two. Whoops, I guess it's not xx, it's x squared. 4x squared plus these guys, which gives me 5x. And then lastly, I deal with these ones, and I get negative 6. So what is my, how many terms do I have? 3, so it's called a and trinomial. And what is the degree on this one? 2. Good. That's it. That's all you need.